For today's lesson, we will be discussing more concepts about tangents, including tangent circles. But first, let's discuss a common tangent. So when we say common tangent, it is a line or a segment that is tangent to two circles in the same plane. So technically, when you say common tangent, that means two circles are sharing the same tangent, or they have the same tangent line or tangent segment. So let's take a look at this example. Let's say you have circle A, this one, and then you have circle B. Now, if you will notice, these two circles, they share, or both of them have a tangent segment, which is this segment CD. So we can say that segment CD is tangent to circle A and circle B. So as you can see, both the circles, they share the same tangent. So that's why it's called a common tangent. Another example is this one. You have circle M and then circle N. So again, the two circles, they are sharing with one tangent, which is segment EF. So this one, you can say that segment EF is tangent to circle M and circle N. So there are two types of common tangent. First is the common internal tangent. So a common tangent which intersects the segment joining the centers of two circles. So when we say internal, if you will try to imagine, that means they are passing through in between the two circles. So to further understand this, let's take a look at this example. Okay, so you have here circle A and then circle B. Now we have here segment CD and segment FE. Okay, so these are common tangents of circle A and circle B, since this one CD, it intersects circle A and also with circle B. Same with segment FE. So there are common tangents. Now, if you will notice, the location of the tangents, they're passing through in between. So if these are the circles, the two circles, they're going through in between the two circles. That's why they are called common internal tangent. Now, another thing that we have to remember is that these two tangents must intersect the segment joining the two centers of the given circles. So let's say we will add a segment, or we will connect point A and point B. The two common tangents here, they intersect the segment connecting the two centers of the given circles. So that means these two tangents are really the common internal tangents. Common internal tangents of circle A and circle B. So aside from the common internal, we also have the common external. So a common tangent which do not intersect the segment joining the centers of the two circles. So it's the other way around. It's the opposite one. So since this is external, so that means the segments or the tangents are not passing through in between the two circles. And one thing that we also have to remember is that this should not intersect the segments joining the centers of the two circles. So example, you have here circle G and then circle T. So again, we have here segment CD and segment AB, which are common tangents of the two circles. Now, if you will notice, comparing it with the previous example, this lies outside the two circles. Okay, so we can say that these are external tangents, common external tangents. One thing that we have to make sure is the segments or the tangents should not intersect the segment connecting the two centers. So if we will try to put or connect point G and point T, you will see that this or the two tangents will not intersect this segment. So aside from tangent segments, you also have what we call as the tangent circles. So these are two circles whose intersection is exactly 1 point. So for example, you have here circle A and then circle B. So we can say that these two circles are tangent circles since these two circles, they intersect at 1 point, which is point C. So if there is only 1 point of intersection or 1 point of tangency, then the two circles are referred as tangent circles. So there are two types of tangent circles. First is the internally tangent circles. So these are circles that are coplanar, share a common point of tangency, and with centers that lie on the same side of their common tangent. So let's say we have here circle A and circle B. So circle A is the larger circle and circle B is the smaller one. So to say if the two circles are internally tangent circles, first is they should have the same or common point of tangency. So in this case, this one, let's try to put here, let's say this is point C. So they just have 1 point of intersection with segment DC. And one thing that we have to consider is that the centers must lie on the same side of the tangent segments. So again, it's either both of them are on the right or on the left. So in this case, both of the circles are on the left of segment DC. Okay, so the conditions are met by these two circles. So circle A and circle B are, we can say that they are now internally tangent circles. So we also have externally tangent circles. So it has the same condition with the first one, but the only difference is the centers lie on opposite sides of their common tangent. So it's either one is on the right and one is on the left. So let's take a look at this one. So you have circle A and circle C. So again, they have this tangent right here and they just have 1 point of tangency. So let's try to name this point. Let's say this is point B. Okay, so to check if the two are externally tangent circles, so first they should have common point of tangency. So we already have that. Next is the centers lie on the opposite sides. So as you can see, circle A is on the left and circle C is on the right. So with that, we can say that circle A and circle C are externally tangent circles. So, and lastly, we have the theorem for tangent circles, which is the tangent circles theorem or theorem 104. So it states that if two circles are tangent, then their centers are collinear with their point of tangency. So we have this word collinear. When we say collinear, that means they lie on the same line or points lying on the same line. So that means the two centers together with the point of tangency are lying on the same line. Let's have these examples. So we have here circle A and circle B, which are obviously tangent circles. And the point of tangency is this one, which is point C. Now, according to the theorem, so if the two circles are tangent circles, then the centers and the point of tangency are collinear. So we can say that A, B, and C are collinear. Or they should lie on the same line. Same as with this one. So let's put here point of tangent C. Let's say this is B. So again, you can say that A, B, and C are collinear. Again, this is based on the tangent circles theorem, or whenever you have tangent circles, then the centers and the point of tangent C are collinear, or they lie on the same line. So that's it for today. I hope you learned something about tangent circles, common tangents, and hope to see you next time.